Welcome to another physics class. During our last lesson, we done everything we need to know under work. So today our topic is energy. And what is energy? Energy can be simply defined as the ability or capacity to do work. Energy is the capacity or ability to do work. That is why we define in our last lesson work as the product of force and the displacement in the direction of the force. So when you now say energy, the capacity or ability to do work. Now, to continue, energy is a scalar quantity. But don't forget, when you say scalar quantity, quantity that has magnitude only without a specified or specific direction. At the same time, energy is measured in joule. That is, the unit of energy is joule. Don't forget, we talk about joule under work, so we now repeat ourselves now. Since energy is measured in joule, it is also a derived quantity. Derived quantity. Now, the next thing is forms, or you call it types of energy. Forms or type of energy. We have different forms of energy. Let's mention but few. One, we have heat energy. Heat energy. Two, solar energy. We have three, chemical energy. We have four, nuclear energy. We have five, gravitational energy. We have six, biomass energy. We have number 7, electrical energy. Number 8, we have mechanical energy. Number 9, wind energy. Number 10, magnetic energy. 11, we have ionization energy. Ionization energy. 12, we have radiant energy, etc. Next thing is sources of energy. We have two major sources of energy. One, renewable source of energy. 2. Non-renewable source of energy. And when you say renewable source of energy, renewable source, these are energy source that can be replenished after use. That is, energy source that can be replenished after use. Energy source, after use, that we can still replace them. Examples of renewable energy, examples of renewable energy source are 1. Wind energy source. 2. Solar energy source. 3. Biomass energy source. Number 4. Tidal energy source. 5. Hydro energy source, that is energy from water. Then 6. Geothermal and etc. That is, all these example mentioned, after use, they can be replaced or replenished. Like, take for example, when is a solar energy source? Solar energy source is energy from the sun. That one can be replaced or replenished. Biomass is energy from either any plant decay or maybe like sugarcane. When they ferment, we can get energy from them, or any green grass that have been fermented. So that is energy from biomass. They can be replaced. So also tidal, that is wave energy. Then hydro, that's energy from water. Then geothermal from the ground. So all those ones can be replenished after use. That is why we call them renewable source of energy. The second one is non-renewable. Non-renewable source of energy. Just the opposite of renewable, that is energy that can not replenish after use. Energy that cannot replenish after use. Examples are 1. The energy from nuclear energy. 2. Energy from natural gas. 3. Then energy from crude oil or petroleum, or we call them fossil fuel. All these examples of energy source are not renewable. Like natural gas, once you use it, it's not renewable. Energy from nuclear energy, the nuclear source are not renewable. From crude oil or petroleum, which are called fossil fuel, they are not renewable. That is why we call them non-renewable source of energy. The next thing is potential and kinetic energy. As we have mentioned, different forms of type of energy. All those types of forms of energy are potential and kinetic in nature. As we can have mechanical potential and kinetic energy, we can have electrical potential and kinetic energy. That is why when you have mechanical potential energy, that is, you talk about mechanical system at rest, like a vehicle at rest. That's mechanical system at rest. At the same time, when you pick electrical energy deal with charges, and we have positive and negative charges. So when you have charge at rest, then you have electrical potential energy. But when the charges are on motion, we have electrical kinetic energy. That is why we say all forms or types of energy are potential and kinetic in nature. Now, what is potential energy? Potential energy. The symbol is P. When you say potential energy, it's the energy that a body possesses due to the value of its position, or you say energy at rest. When an object is at rest, in any case or form of energy, then that type of energy is potential energy. For example, when you have a vehicle at rest, that is mechanical system, then the type of energy possessed is potential energy. When a vehicle is on motion, the type of energy possessed there, since it is on motion, and kinetic energy deal with motion. So the type of energy possessed by a vehicle on motion is kinetic energy. That is the simple definition of potential energy, that is energy at rest or energy possessed by a body due to its value of its position. Then, now let's talk about types of P, that is types of potential energy. Types of potential energy. As I said the other time, all forms of energy are potential and kinetic in nature. Let's mention but few now. One, we have electrical potential energy. Two, we can have elastic potential energy. That is energy possessed by an elastic material at rest. We have three, gravitational potential energy, that is energy possessed by a body or a mass on the surface of the earth. We call it gravitational potential energy. Four, chemical potential energy. And when you see chemical potential energy, that is energy stored in the molecules of a fluid at rest. So we call it chemical potential energy. So to mention but few, as I said the other time, all those forms of type of energy can be potential and kinetic in nature. So you can use any one. Once it is at rest, then we have what we call potential energy. Now the next thing is magnitude. Magnitude of potential energy. Magnitude of potential energy. Now, the magnitude of potential energy, the magnitude of potential energy is given as P is equal to mgh. P is equal to mgh, where m is equal to mass of the body, g is acceleration due to gravity, then h is the height or vertical distance, or you call it height of an object. So that's the magnitude of the potential energy. It means the magnitude of potential energy is affected by three factors. One, the mass of the body itself. Two, acceleration due to gravity. And three, height or this vertical distance of the object on the surface. Now the next thing is kinetic energy. Kinetic energy. The symbol for this one is Ke. So when you say kinetic energy, as I said, is energy possessed by a body due to its virtue of its motion. Energy possessed by a body due to its virtue of its motion. In short, we can now say Ke is energy at motion. That is, when an object is on motion, the type of energy possessed is kinetic energy. So K is energy at motion or energy possessed by a body when it is on motion. Now, we can also have different types of kinetic energy, types of Ke. As we have here, electrical potential energy when you have charges at rest. Then we can also have electrical kinetic energy. One, electrical kinetic energy. You can have two, elastic kinetic energy. Then we can have three, gravitational kinetic energy. Then at the same time we can have chemical kinetic energy. Just when the object is on motion, then we have what we call kinetic energy. At the same time, kinetic energy can also be classified in terms of type of motion that object is observing. That is, it depends on the type of object type of motion that a particular object is undergoing. For instance, when an object is undergoing a straight line motion. Then we are going to have translational kinetic energy. When the object is rotating, like when you have charges rotating, then you have rotational kinetic energy. So it depends on the type of motion a particular object is undergoing. So that is why we can have also it can be classified in terms of motion and object is performing. E.g., one, we have translational kinetic energy. That is energy of an object in a straight line. So also, number two, we can have rotational kinetic energy. That is energy of an object in circular path. We can have vibratory kinetic energy. That is energy of an object, that is vibrating. Energy of an object that is vibrating. For instance, when you heat a solid material, definitely the molecules of that solid material will vibrate. So such molecule will have what we call vibrating kinetic energy. Next is magnitude of Ke. Case of potential energy, in which the magnitude is mgh, then the magnitude of kinetic energy is given as half mv squared, where m is equal to mass of the body, v is velocity or speed at which the object is moving, velocity of the body, that is, the magnitude of kinetic energy depends on two quantities, that is the mass and the velocity of the body. Let's talk about differences between P and Ke. Let's do in a tabular form. P, then Ke. According to the definition, P is energy at rest, while Ke is energy on motion. That's number one. Number two, P is energy against particle distance. While this one is energy on horizontal level. Then number three, gravity has effect on it, where this one, potential gravity, has no effect on it. Then the last, number four, this one denoted by PE, while this one is denoted by KE. Number five, the magnitude is given as mgh, while on the other hand, the magnitude is given as half mv squared. The possible differences between the two quantities, that is the potential energy and kinetic energy. Now the next thing, let's talk about similarity between them. Similarities between P and Ke. 1. Both are forms of energy. That is why I said the other time, all forms of energy are potential and kinetic in nature. 2. Both are scalar quantities. 3. Both are measured in joule. So these are the three similarities between the two quantities. The next thing is, the question can ask you to state examples of potential energy and to state examples of kinetic energy. That one is very simple. When it is under potential energy, just put it in mind, anything at rest is a typical example of potential energy. Anybody, a body at rest, a vehicle at rest, a stone at rest, anything at rest is a typical example of potential energy. And on the other hand, when you talk about kinetic energy, anything on motion is a typical example of kinetic energy, like a vehicle on motion, a vibrating molecules, a moving charges. So all those ones are typical. Anything of motion in short is a typical examples of kinetic energy. That's for the examples of both. Now the next thing is relationship between work done and kinetic energy. Now we want to find the relationship between work done and the kinetic energy. Now, from our last lesson, already we know that work done is equal to force multiplied by displacement. And here now, we've seen that kinetic energy, K, is equal to half mv squared. Then how are these two quantities related together? This is what you want to look at now. That is, you can say work done is equal to force multiplied by the same by displacement, which is equal to half K. That is what we want to prove now is that work done is equal to Ke, which is equal to half mv squared. We want to show this relationship, how we can arrive at this one. And to start with, note work done already we know is equal to force multiplied by displacement. And force, as we know, is equal to, we can now say, but F is equal to MA. So we can now say work done is equal to MAD. And under this one, we don't need A. Let's substitute for A from linear equation of motion. We can now say from linear motion, we know that V squared is equal to U squared plus 2AS. Now in this equation now, let's make A the subject of the formula. Mind you, this is initial velocity, where this one is final velocity. For any work to be done, according to what we are looking at, that the object must first be at rest. If the object is at rest, we can now say U is equal to 0. Object that is at rest. If it has rest and U is equal to 0, so we have V squared is equal to 2AS. Make A the subject of the formula now. A now is equal to V squared over 2S. If that is the case now, come here now, from this one now, we now say from work done, which is equal to MAD, substitute for A now. Now from this one now, we want to substitute for A. And mind you, our S here is also distant. So we can now say, instead of using two variables, let's change this one also to D, and D, to retain just one variable. So we are going to have our work done now. Work done, we want to remove A. That will be M into our A here. Our A here is V squared over 2D. Then multiply by D. So D will cancel D. We have work done equal to MV squared over 2, which is the same thing as half mv squared. So we can now say that work done is equal to half mv squared, which is equal to Ke. That is the relationship between work done and kinetic energy. Or in another way, another method of deriving this equation or this formula or relationship between work done and kinetic energy. So you can use this method depending on the question given to you. But mind you, in calculation, you may come across all these formula and you need to apply them. So that is why we need to use another method now. So for this one now, we now say our work done is equal to F multiplied by D. Take the next step, that is our MAD. Now, to remove this A now say from linear motion, we know that V is equal to U plus AT. Now, make A the subject of the formula. Don't forget, since the other time we said U must be equal to 0 because your object must start at rest. So U is equal to 0 without wasting time. Object at rest. So we have V now is equal to AT. So our A now is equal to V over T. Come here now and remove A. So we are going to have our work done will be equal to, that is MAD, remove A. We are going to have M into V over TD. So that is the work done. Now, don't forget, this our D, under this one, this our D is the horizontal distance. And you know that where D is distance, and you know that the average speed, that distance, and as I said, this D is the distance, that is the total distance, and the total distance D is equal to average speed multiplied by time taken, where the average speed will be equal to V plus U over 2 into T. Mind you, our U remains 0. U is equal to 0. So you have V over 2T. So from there now, if you come here now, since work done is equal to MV over TD, now remove D here now. Put V over 2D. So we are going to have our work done will be equal to M into V over T. Now to remove this D now, that will be dot V over 2T. So T will cancel T. So we are going to have our work done, which will be equal to MV square over 2, then which is the same thing as half MV square. So in short, we can now say that from what we've done here now, we can now say that work done is equal to half MV square is equal to KE. So any method you like, when you have to prove that work done is equal to half MV square is equal to KE, you can use any of this method to prove yourself out. By using the two methods, anyone you like best, you switch it and prove it out. And this will be the convenient point to stop for now. In our next lesson, we are going to use both the formula of potential energy, kinetic energy, and the relationship between the work done and kinetic energy to solve some problem under this topic. And as I always say, if you are just joining us, please try to like, share, and subscribe. So when I upload a new video, you'll be able to get the notification in time. Thank you.